Hi grade 9s, we are finally on to topic 2 in Algebra 2. So you'll remember that when we started Algebra 2, we've just finished a whole long section which was all under a subheading of topic 1. And that was the 3 different types of factorizing. So there was highest common factor, dots, and then trinomials. Now that took us a while because it's such a big new concept for us, and there were lots of different things that can happen under each heading. Now finally we can see just one of the places. We are going to see multiple places this year, and then by the time you're in matric, gosh, you'll be amazed at how much factorizing can be used. But we're just going to look now at one example of where factorizing can help us. And so this is topic 2, which is fractions. Don't forget to write down our notes as we go. Right, so 2.1, there's 2 subtopics in fractions, and the first one is simplifying fractions. So example 1 says simplify. And question A says 20x squared y to the power of 4 over 5x y to the power of 6. Now, you should kind of recognize those questions because this is exactly the same as the type of the question that we did in exponents. So we have been doing fractions for a while. Now, I hope we've probably never mentioned this before because it wasn't necessary, but do you notice that there's one term at the top of this fraction? And if I look at the bottom, there's one term at the bottom. Now that's really important. We probably haven't really mentioned it till now, but this is probably one of the most important things that I will teach you this year. So I'm going to write it in red. Most importantly, we can only ever simplify. We can only ever simplify fractions when there is one term at the top and one term at the bottom. So when there is one term over one term. Now, we probably haven't mentioned it up until now because you've always had one term over one term. So if I look at this particular question, it is one term over one term, and so what I would do is I would just simplify. And how I would simplify is signs, numbers, variables. So there's no signs here to worry about. Your numbers, it's 20 divided by 5, which is 4. Variables, you have 2 x's at the top and 1 at the bottom, so you'll be left with 1 at the top. Y's, you have 6 at the bottom and 4 at the top, so you're going to be left with 2 once you finish cancelling, but they will be at the bottom. Now the only reason we could do that is because it was one term over one term. So that should be fairly familiar to us. If we look at question B, the first thing I now need to be asking myself is, do I have one term over one term? So before I launch, most important question, do I have one term over one term? Now this is going to be something that you're probably going to say to yourself a million times before the end of high school. It's a really, really important concept. Now the answer here is yes. The top is one term. It looks a little bit not like one term because it's multiplied, but don't forget multiplication glues factors together to form a term. So while the top isn't simplified, it is one term. So my first step here in exponents would have been to simplify the top. So 2 times 4 is 8. A squared times a to the power of 1. Don't forget when you multiply powers the same base, you add exponents. And b's, when you multiply powers the same base, so that was meant to be a 1, you add exponents over 16a cubed b to the power of 4. So now I've simplified the top. I now can divide my fractions. So signs, numbers, variables. 8 goes into itself once, goes into 16 twice. Don't be tempted to say 2 because 8 over 16, your brain will say 2, but just be careful, it's a half. Now if you have 3 a's at the top and 3 a's at the bottom, you're not left with any a's, so they disappear. And b to the power of, that's meant to say a 6, divided by b to the power of 4, you'll be left with 2 at the top. So this 1 there actually could have been left out, so you can leave it in or you can leave it out. Now A and B, you'll notice I haven't written lots of notes because that was part of the exponent section. I just wanted to start with that because those are the fractions we have been simplifying. And we have been simplifying them because they're one term over one term. So now the question is, how do we simplify if there's not one term over one term? So example 2 says simplify. Now what's really difficult about example 2 is the instruction says simplify. And yet very shortly I'm going to tell us to factorize. So just take note that sometimes, even though the instruction says simplify, we can use factorizing to help us simplify. It seems like we're going backwards, but it's almost like you're going one step back so that you can go 2 steps forward. So we can use factorizing to allow us to simplify. So I know they seem like opposite processes, and they are, but 1 step backwards, 2 steps forward. Okay, so let's have a look at A. Alarm bells need to go off. Absolute alarm bells. This is not one term at the top. And we can only start cancelling stuff out and simplifying when we have one term over one term. So I cannot have more than one term at the top. So I need one term at the top. Now this is why right at the beginning of factorizing, in my first lesson, I said something really important, and that was the whole point of factorizing is to take multiple terms and make them into one term. So I'm going to write that down here. The whole aim of factorizing, is to make multiple terms into one term. To make multiple terms into one term. Now, why do we need to do that here? Let's look at a couple of scenarios. If I gave you this question and just said do it without thinking, lots of people would say, oh look, 3 divided by 3 disappears, and the answer is x plus 9. So that's one of the versions that people could do. Some people could say, oh hang on, why divide the 3 by the 3? I could say 3 goes into 9 3 times, and then the answer is 3x plus 3. Now, the problem is neither of these are right, because what you've done, in the yellow, you've decided to only divide the 9 by 3. Whereas in the blue, you've decided to only divide the 3x by 3. And the reality is that both of those terms on top are divided by 3. So you can't select which term you want to divide by 3. In actual fact, this technically comes from 3x divided by 3 and 9 divided by 3. Now that's a perfectly acceptable statement. There's nothing wrong. I don't know if you remember when we first do fractions in grades 6 and 7. The idea was if you're trying to add fractions, write them with the lowest common denominator, because then you can just add the tops and leave the denominator as 3. So this, if I kind of undo writing it as one fraction, each of these terms on top are divisible by 3. Well, not are divisible, have to be divided by 3. So in which case, the 3's would cancel in the first term, and you'll get x, and 9 divided by 3 is 3. So this is one way to do this question. So I'm just going to write myself a note here. Each term needs to be divided by 3. So this is a perfectly acceptable way to do this question. Now the only problem with doing it this way is that very shortly I'm going to show you an example of where you can't do this. And so in actual fact we prefer not to do it this way. What we prefer to do, let me just choose a different color, is or to make it one term over one term, we factorize. So I'm going to say or we factorize the top. And then when it's one term over one term, we can do as much cancelling as we want. So if I have 3x plus 9 over 3, I say to myself, well, the denominator is one term, so that's fine. The numerator is not. So what's the first thing I check for when I'm factorizing? I'm hoping we remember. It's a highest common factor. So I take out a highest common factor of 3, which leaves me with x plus 3. Now, because it's one term over one term, you can cancel anything you want. And you'll notice that the 3's cancel. And I'm left with x plus 3, which is the same answer as the previous method. Now again, we don't like the method in blue simply because it does not work for every question. In fact, very shortly you're going to figure out that it works for very few questions, and we'll see why. And so we prefer to factorize everything we can and then cancel. So let's have a look at B. My first thing I say to myself, alarm bells, is it one term over one term? If it's not, I cannot factorize. I cannot not factorize. I cannot simplify until it is one term over one term. So the answer here is no, it's not. And so before I do anything to make it one term over one term, we factorize. Absolutely everything that isn't one term, we factorize. In this case, so to make it one term over one term, we factorize. So it seems like we're going backwards because the question said simplify, but we actually factorize to simplify. Now you'll notice here that the denominator is one term. So the denominator I'm going to leave because it clearly doesn't need to be factorized. So 2ab squared. The top, however, is not one term. So I'm going to factorize this. Factorize. And the first thing I do when I factorize is I look for a highest common factor. Now my highest common factor there is definitely a 2. And I've got a squared and a. So a. And then there's a b cubed. So b cubed will be common because the other term has a b to the power of 5. So if I extend my fraction quickly, what do I need in the bracket? Well, what do I need to multiply 2ab cubed by if I need 2a squared? So I definitely need an a, and then I think I'm fine. And now I need to multiply by minus 2, and I've got an a, but I need b to the power of 5, so I'm missing 2 of them. Now the moment it's one term over one term, we can now simplify anything we want. So I'm going to say we can now cancel, which is a method of simplifying. So we can now cancel or simplify anything simply because we have one term over one term. Now when I say anything, just be careful. A bracket can only be cancelled with an entire identical bracket. So let me write that just as a note here. So brackets, I always say when I teach the second section that brackets are like a Happy Meal. You can't possibly go to McDonald's and say, can I just have the toy? No, you need to buy the whole meal. So brackets are like a Happy Meal. You can only cancel a bracket if you cancel it with an entire identical bracket. So you can only cancel a bracket if you cancel it with an entire identical bracket. So you can't see the A inside the bracket and go, oh yes, A and A. No. You can't pick out the toy from the Happy Meal. It's either the whole Happy Meal or nothing. So what I can do here is say, oh gosh, look. Now I'm going to do this. Oh, no, that wasn't meant to happen. There was meant to be a 2 there, and I cancelled it away. So let me go put it back there. What I can do now is I say, right, 2 goes into itself once. A goes into itself once. Now, if you look at the B's, if I have 3 B's on the top and 2 at the bottom, I'll be left with 1 at the top. Now, just be careful. This whole cancelling out, I need to be able to see your highest common factor. So if you are going to cancel like I have now, just do it lightly in pencil. And then I'm afraid the whole bracket is still there. And there we go. Now, that doesn't look very pretty because it's not really multiplied out. And so I would possibly multiply this out now. So that's AB, and that's minus 2b cubed. So I would now go and multiply that out. So we factorize to make something one term over one term so that we can cancel. Okay, now notice I could have done the first method. I could have split this into 2 different denominators. So what I could have done here, I'm just going to write it in, is I could have said that it's 2a squared b cubed divided by 2ab squared, and it's 4ab to the power of 5 over 2ab squared, and you would have gotten exactly the same answer when you simplified each term. However, let me say this again, it doesn't work for all fractions. And so I'll show you the question after the next one. I'm going to show you an example of where it doesn't work, and that's why we generally try and avoid that method. Okay, question C. gosh, it's not one term over one term, so we need to factorize. So it's not one term over one term, so don't go cancelling things willy-nilly. I promise you're all going to make this mistake. So alarm bells must go off the moment you see a fraction. So I need to factorize. So if I look at the top, the numerator is not one term, the denominator is. So the numerator, highest common factor, definitely a 3 and I think an x. Because then I'll be missing an x to make x squared and a y. And plus 2y and then minus 3. So don't forget to multiply out, just check if you got that right. Now what can cancel? The 3's can cancel. Don't forget to do this very lightly. The x's can cancel, and that's it. Now you can't start going, oh, is that y can cancel with that? You can't start doing that, because don't forget you're not allowed to pick and choose out of the Happy Meal. It's either the entire Happy Meal or nothing. So I land up with, at the top, xy plus 2y minus 3, and at the bottom, y squared. And that y squared again cannot cancel with those y's, because those y's are part of a bracket. Right, let's look at D. Now D is the perfect example of why our old method of splitting into fractions is not going to work. Because look, the denominator is 2 terms. So this, you can split it up. You can say this is x squared over x minus 2, but then nothing can cancel because there's still 2 terms at the bottom. So this doesn't help splitting it up, and so this is exactly why we learn to factorize. So I need to factorize to make it 1 term over 1 term. Now this is our first example of where the denominator is also not 1 term. So let's look at the top. I first say to myself, do I have a highest common factor? And x squared and minus 4 don't look like they have a highest common factor. So it's a binomial times a binomial. Why do I know that? Well, it's a dots. So after I've checked a highest common factor, I next check a dots. It's not a trinomial, but it is a dots, so we haven't done dots in a while. Don't forget that the brackets are identical. And I say what times itself gives me x squared, what times itself gives me 4, and one's a plus and one's a minus. Now if I look at this denominator, I say, right, I need a highest common factor. No. Dots? No. Trinomial? No. So x minus 2 can't factorize. Now that makes me a little bit nervous because it has to become 1 term. So what can I do to make something 1 term? You can just put a bracket around it. Now that works for everything. You can put a bracket around anything and then it's 1 term. But if it's not identical to something else, it's not going to help. So I'm just going to write myself a note here. So note, to make this 1 term, I simply put a bracket around this. To make this 1 term, now this is only because it didn't factorize. It's only when I'm desperate that I do this. So to make this 1 term, we simply put a bracket around it. Now why did that work in this particular example is because if you look at this question, there is another x minus 2. So only when I'm desperate do I put a bracket around it and go, oh my word, wonderful. An entire bracket can cancel with an entire bracket. Remember, you cannot pick parts out of the Happy Meal. So you can't cancel parts with, so I couldn't possibly say, for example, oh, that x will cancel with that x. No, that's not how it works. An entire bracket or nothing. So I'm just going to write that here. Remember, we can only cancel entire identical brackets. And even write yourself the note about the Happy Meal if you think it'll help. You can't have the Happy Meal toy without the whole meal. And so this answer was x plus 2. Okay, let's try some more. Question E, oh my word, it's not 1 term over 1 term, so I need to factorize. So step number 1 is check. Is it 1 term over 1 term? If the answer is yes, then go wild. Go simplify as much as you want. That's what we did in example 1. If the answer is no, then what you need to do is you need to factorize everything you can. then you can cancel. So in this question, my x squared at the bottom doesn't need to factorize, it's one term, but at the top, I'm going to take out a highest common factor of 5x, which means 5x times 1 will give itself back, plus 3x. So once you have one term over one term, you can now cancel anything. Well, I say anything, but you know what I mean. You can't cancel brackets unless they're identical, but anything that's identical you can cancel. So in this particular example, one of these x's can cancel with one of those. So I actually land up with getting 1x at the bottom and a 5 and a 1 plus 3x at the top. Now there's no reason that you actually need to multiply this out here, simply because you can't go any further, you can't get any better. Personally, I like to multiply out the top, but I don't know why, it doesn't actually matter. So I would put 5 possibly back in, but these are equally as simple, simply because there is no way to cancel anything more. And so I would accept both of those as an answer. Okay, let's try the next one. Question F, is it one term over one term? Oh gosh, no it's not, so I need to factorize. So at the top, I'm going to take out a highest common factor of a, which leaves me with a squared plus 2. And at the bottom, I have a squared plus 2, and it doesn't have a highest common factor, and it's not a dots, and it's not a trinomial, so I start to get a bit panicky. But don't forget, if you're desperate, you can simply put a bracket around that, and if it's identical to another bracket, it does land up cancelling. And so in this case, oh sorry, that wasn't meant to happen. In this case, the entire bracket can cancel. Don't forget to do that lightly so I can see your factorizing. And your answer is just A. So that's another example of where you're desperate, you can put a bracket around it and then cancel with an entire other bracket. Right, on to G. You'll notice that these are all the same. Oh gosh, there's not one term over one term, so I need to factorize. So I take out a highest common factor of a squared at the top, which leaves me with a plus 2 in the bracket over a cubed. And now that it's one term over one term, there isn't an identical bracket to cancel with, but if I have 3 a's at the bottom and 2 at the top, 3 a's at the bottom, 2 at the top, I'm going to land up with 1 at the bottom and my a plus 2. Now you can't cancel those a's because that a at the top is part of a bracket. So it's all or nothing with a bracket. Right, soldiering on. Question H. Question H, gosh, it isn't one term over one term. If I look at the top, x plus 4, no highest common factor, no dots, no trinomial, and so I think I'm desperate, I'm going to put a bracket around it. So I hope there's an identical bracket to cancel with. Now I think there is going to be, because x squared minus 16 is a dots. And x times x will give me 16. 4 times 4 will give me, x times x give me x squared. You can tell I'm tired. 4 times 4 gives me 16. 1's a plus, 1's a minus. Now that's perfect because x plus 4 cancels the x plus 4. Now I chose this example because then people get confused with what's left and they just say the answer is x minus 4. Just be careful, the answer is x minus 4, but at the bottom of a fraction. Now what's at the top? Well, technically, every time we cancel, we should say x plus 4 goes into itself once. So this is actually 1 over x minus 4. Right, let's have a look at our last couple of ones. This isn't one term of one term, so I'm going to factorize. The top, I'm going to take out a highest common factor of 3, so I get x squared minus 9. And the bottom, I'm going to take out a 3, and I get x minus 3. So now, I would think, gosh, that's wonderful, the 3's are going to cancel. But hopefully you saw the x squared minus 9 and something jumped into your head. That isn't fully factorized, because x squared minus 9 is now a dots. Now you'll be able to tell from your mark allocation, because if you just did a highest common factor and a highest common factor and cancelled, it'll probably be a 2-mark question. Whereas this would be a 3 to 4-mark question, because the top is now a dots again. And x times x and 3 times 3, 1's a plus, 1's a minus. So don't forget, after you take out a highest common factor, look if there's a dot or a trinomial. So now it is fully factorized, and my x minus 3 can cancel, and my 3's can cancel, which actually means I'm simply left with x plus 3. So just don't forget to fully factorize everything. Right, on to question K. This is our first example of where we have a trinomial. So if I look x squared minus x minus 6, I'm so used to seeing trinomials now that I recognize that the bottom is x minus 3. Now I'm going to just show you a little bit of a trick here. I've checked x minus 3. It doesn't have a highest common factor. It's not a dot. It's not a trinomial, which means I'm going to force it to be one term by bracketing it. Now, why would they ask me a question if something couldn't cancel? So I can pretty much bet that there's going to have to be an x minus 3 at the top. Otherwise, this would be a rather silly question. So you can kind of do shortcuts when you're factorizing trinomials. Now let's check. I would need an x, and I would need 3 times 2. Now my signs need to be different, so this would have to be a plus 2. Now let me just quickly multiply this out, because I was kind of cheating to make this work, but let's check. X times x, x squared, plus 2x, minus 3x, minus 6. And what do you know? That gives me minus 1x, which is the right middle term. So I was doing a bit of cheating here, only because they wouldn't ask me a question that didn't have anything to cancel. And so, sorry, I was cheating a bit. Nothing wrong with that. X minus 3 cancels, and I'm left with x plus 2. Right, I think this is the last example. So if we have a look, definitely a trinomial on the top, and the bottom looks like a dot. Now you'll notice factorizing you start to get really good at, because you've just seen everything before. I mean, I saw x squared minus 9 like 2 questions ago. So x times x, 3 times 3 is a dot, 1's a plus, 1's a minus. Which means I can pretty much guess that there's going to be an x minus 3 or an x plus 3 at the top. So I don't have to do too much work for my trinomial. I know it's x, and I know it's x, and I know it must be a 3, because otherwise this question is silly. I don't know if it's plus 3 or minus 3 yet. So let's have a look. It's minus 12. So I know my options has to be 4 times 3. There's no point in checking 6 times 2, because then nothing would cancel, and there's no point in checking 12 times 1. So I think it's 3 times 4, but my signs must be different. And my middle term is plus 1. So these somehow have to add to give me plus 1x. So I think it's plus 4, take away 3 to give me plus 1 in the middle. So again, a little bit of cheating there. And now I know that x minus 3 cancels with x minus 3. And I'm actually left with x plus 4 over x plus 3. Okay, so this was our first way of using factorizing. Even though the question says simplify, which is what kind of confuses people, sometimes we have to factorize to be able to simplify. And when we need to factorize is when you have fractions, you can only simplify when it's one term over one term, which means we need to factorize to create that one term over one term, and then we can cancel. Things to remember, don't forget, it's all or nothing with a bracket. So either the entire bracket cancels with an identical bracket, or nothing can happen with that bracket. Okay, so hopefully you'll get better and better at factorizing as you practice this. We're now going to do exercise 18.12 on page 248. So obviously, hopefully you've watched this, you've taken down the notes. Try exercise 18.12 now, mark it from the memo, and don't forget to ask questions whenever you have problems. Okay, well done. Keep it up.